Welcome to today's Explainer. We're diving into a massive, fundamental shift in how the world around us is literally built. Modern electronic engineering is completely moving away from those old physical workbenches cluttered with wires and soldering irons. Instead, it's moving into highly intelligent, totally virtual environments. If you want to understand how cutting-edge tech actually goes from a raw concept to scalable reality, well, you are in the exact right place.
So how do you perfect a complex electronic system before it even exists? It sounds kind of like a paradox, right? Historically, engineering meant a whole lot of trial and error. You build it, you test it, something short circuits, cue the dreaded smell of burning silicon, you figure out why, and you start all over again. It's a process just fraught with friction, wasted resources, and lost time. But what if you could know exactly how a system would perform under pressure without ever physically building it? That is the exact challenge modern engineering innovation is solving today.
Okay, let's dive into this. Here's our roadmap for today. First up, we'll look at the prototyping problem. Second, the multisim solution. Third, bridging analog and digital. Fourth, collaborative engineering workflows. And finally, how this is all shaping future engineers.
Section 1. The prototyping problem and the hidden costs of physical builds.
To really appreciate the solution here, we first have to understand the antagonist of our story, traditional prototyping. Honestly, it's a massive bottleneck. It requires considerable time and resources, and those physical development procedures are just incredibly slow. If a component fails, you have to source a new one, rebuild the whole thing, and retest. Multisim flips this entirely by acting as a digital twin. Engineers can run comprehensive virtual evaluations, proactively optimize systems, and improve reliability in a virtual sandbox way before a single physical part is ever ordered. It's literally the difference between hoping a design works and mathematically proving it will.
Section 2. The Multisim solution, focusing on intelligent simulation technologies. So, what is the tool actually solving this? Multisim is defined as a comprehensive circuit simulation environment, but in practice, it's a virtual proving ground. It enables professionals to design, simulate, and fully validate intelligent electronic systems long before any physical implementation. It essentially takes the guesswork out of circuit design, letting you deeply analyze how components behave and interact on a highly intelligent framework.
This creates a completely new, virtually frictionless workflow. Step 1, you start with a conceptual idea. Step 2, intelligent virtual simulation. This is where Multisim really shines, allowing you to test that idea in a simulated operational environment. Step 3 is where the magic happens, iterative design improvements. Because you're in a virtual space, you can tweak, break, and fix things in seconds to instantly evaluate your design choices. And finally, Step 4, scalable physical implementation. By the time you reach this stage, the system is already perfected.
Section 3. Bridging analog and digital through system modeling.
Modern electronic systems are incredibly demanding, requiring architectures that speak multiple technological languages at once. Now, what's really interesting about this slide is how it breaks down these systems. Intelligent systems increasingly integrate sophisticated, continuous analog operations right alongside advanced digital operations for automation and communication tech. Multisim integrates both seamlessly. It gives engineers interactive simulation environments for the analog side and comprehensive architecture evaluation for the digital side, all in one place.
Section 4. Collaborative engineering workflows, because engineering is definitely a team sport.
The days of the solo inventor tinkering alone in a garage are pretty much behind us. Today, tech projects are expanding massively in complexity, managing large-scale operations that require uniting multidisciplinary teams handling interconnected designs. And this brilliantly illustrates how we solve that problem. Effective communication is absolutely crucial here. Multisim transforms sophisticated concepts into accessible, intuitive virtual simulations that the whole team can grasp. Plus, it leverages cloud-enabled ecosystems for distributed collaboration. This is huge. It means an engineer in Tokyo can evaluate a project with a designer in Berlin seamlessly.
Section 5. Shaping future engineers and preparing for rapidly evolving landscapes. We've talked a lot about the technology, but let's look at the human impact for a second. The source material highlights this perfectly, stating, developing competencies related to electronic system design significantly strengthens professional preparedness throughout rapidly evolving technological landscapes worldwide. Educational institutions recognize this strategic shift for sure. By using platforms like Multisim, aspiring engineers aren't just learning theory on a chalkboard. They're gaining hands-on, vital preparedness for the exact high-stakes environments they're going to soon enter.
When you pull back and look at the big picture, the benefits are just undeniable. We're talking about a platform that supports cutting-edge industrial IoT applications and empowers researchers, students, and engineers globally. It seamlessly combines advanced engineering rigor with emerging digital innovations, delivering scalable, sustainable, and truly future-ready solutions. I want to leave you with this final thought. How will digital transformation and virtual simulation reshape the next electronic gadget you use? Seriously, the next time you pick up a smart device, remember that before it was physical glass and metal, it was a perfectly optimized virtual simulation. Thank you so much for joining me for this explainer. Keep learning, and I'll catch you next time.